everyone. In this video, we are going to derive the unit circle. First of all, let's talk about what is the unit circle. So the unit circle is a circle with a radius of 1. And the equation for the unit circle is x squared plus y squared equals 1. If you remember, the equation of a circle is written as x squared plus y squared equals the radius squared. So you can tell with this unit circle that this 1 right here, the square root of 1, is going to be our radius, which is 1. So let's graph this circle on our graph paper over here. So if this circle has a radius of 1 and it's centered about the origin, so we would come over from the origin 1 unit, and we'll put a point right here. It crosses the x-axis right here at 1, 0. And then if we go up on the y-axis, it's going to cross the y-axis at the point 0, 1. And then again, it'll cross the x-axis over here at the point negative 1, 0. And then it'll cross the y-axis down here at the point 0, negative 1. So if we go ahead and do a quick sketch of this circle, I'll try to make it as round as I can. That is our unit circle. So just kind of in relation, this is what it would look like if you graphed it on graph paper. But now what we're going to do is we're going to zoom in on this. We're going to blow it up bigger. And we're going to take a look at it, and we're going to find different points around this circle. Because remember, there's an infinite number of points that make up this circle. But we're going to look at some key points. That's going to be the basis of all our trigonometry that we're going to talk about in other videos. So here's our unit circle blowed up. So here are the points that we just graphed. We graphed this point over here, which is 1, 0. We graphed a point up here, which is 0, 1. And we graph the point over here to the left, which is negative 1, 0. And then we graph the point here at the bottom, which was 0, negative 1. Okay, so here's what's cool about the unit circle. With a unit circle, you take a number line and you wrap it around this circle to measure the circumference. But the units on that number line are based off of the radius of the circle. So when I go to wrap this around, like if you could imagine this distance being wrapped around this way, kind of where 1 might fall, like 1 unit. And then maybe 2 units over here, 3 units would fall right about here. Can you think about what number is pretty close to 3 that might be halfway around this circle? Well, if you said pi, you are correct. So pi falls in this spot right here on the unit circle. And think about that. Pi is like saying 180 degrees, and 180 degrees is the measurement of a straight line. So now what we're going to do is we're going to take that pi and we're going to divide it up into pieces. So let's start by halves. So if I take this circle, and let's take this top half, and we're going to divide it by 2. So we're going to take pi and we're going to divide it by 2. So that means right here, this is where pi over 2 is going to fall. Okay? Now, if I continue going around the circle and I go all the way back around the other half, you guessed it, 2 pi is going to fall right over here. Okay? And let's not forget, initially, I started counting at 0. So think about it. If you can imagine this number line, we put 0 right here on that number line. That number line gets wrapped around, and pi over 2 falls here, and then pi falls here. And then what's going to fall in this spot right here? Well, 3 pi over 2. So 3 pi over 2 falls here. Okay? Now what we're going to do is we're going to divide up the circle even more. So I'm going to look right now at like the top half of this circle. So if you can imagine above the x-axis, we know that that is pi. Going all the way from here around is pi. So if we take pi and we start dividing it into pieces. So we're going to divide now into 4 pieces. So if you can imagine, we'll go from here to here to here to here to here, dividing that into 4 pieces. And that would give us, at this point right here, we would have pi over 4. Okay, and as we count, this is pi over 4, 1 pi over 4, 2 pi over 4. Then right here we would have what? 3 pi over 4. Okay, and then we got 4 pi over 4, and then here we would have 5 pi over 4, and then we keep going around, and then we'd have 6 pi over 4, and then right here would be 7 pi over 4. Now we need to find the coordinate points for these. So in order to do that, we need to do a little bit of special right triangles is what I'm trying to say. So if you could imagine drawing a triangle like right here, that would be a right triangle, okay? Since this is pi over 4, if you can imagine 180 degrees divided by 4, what would be the measurements of that triangle? And actually, I'm going to draw that triangle in here so we can see it. Let me get a different color. Okay, so right here, if I draw this triangle, looks like this. Okay, and if I drop straight down from here, there's my right angle. And this makes a 45, 45, 90-degree triangle. And if you remember from special right triangles, with a 45, 45 triangle, these two sides have the same measure. So like if I call this side A and that side A, then the hypotenuse is going to be the square root of 2 times A. Well, y'all, if this is the unit circle, what does this hypotenuse measure? I'm going to compare this to this right here. So what does that measure? Okay, 1, because the radius of this unit circle is 1. So that means I would take the square root of 2a, set that equal to 1, divide by the square root of 2. So a equals 1 over the square root of 2. And you know us mathematicians, we love to rationalize. So we have to rationalize this fraction. So we're going to multiply by the square root of 2 over the square root of 2. And I don't have room, so I'm going to come down here. Okay, and when I do that, I get square root of 2 over 2. So that tells me that's going to be my A. My x value on this side and my y value on this side are going to be the same. So that's going to be A. Okay. So let me erase this for just a second. Okay, and I'll write that in. All right, so here we go. So this coordinate points here are going to be the square root of 2 over 2 and the square root of 2 over 2. So as we go around this circle and we hit our next value over 4, we'll have the same triangle drawn over here. It's still a 45, 45, 90, but now it's in the second quadrant, so the only thing that's going to change are the signs. So at 3 pi over 4, we're going to have negative square root of 2 over 2, square root of 2 over 2. And then we go into the third quadrant, same thing, except both of them will have a negative sign. So we get negative square root of 2 over 2, negative square root of 2 over 2. Okay, and then in the fourth quadrant, we'll have a positive negative, so we'll have square root of 2 over 2 and negative square root of 2 over 2. Okay, so now let's take a look at more values on the circle. If we keep counting around, now let's take the top half of the circle and let's divide it into thirds. So we'll have a third that kind of falls here, a third that falls here, and a third that falls here. Okay, so let's count that. So we're going to go here, and that is going to be pi over 3. And then we come over here, we have 2 pi over 3. And then as we come here, that's 3 pi over 3, which is the same as pi. And then we come down here, right here, and that's going to be, since this is 3 pi over 3, then now we'll have 4 pi over 3. And then we'll have 5 pi over 3 here. And then back around to 6 pi over 3, which is the same thing as 2 pi. Okay, so now let's look at those values. And let me erase this right here for just a second. I'll have to rewrite that pi over 4 just to kind of get that out the way. So there we go. Now let's look at the values for pi over 3. So if I draw a right triangle here, it's going to look like this. And y'all, if I take 180 and I divide it by 3, what am I going to get? Yes, 60 degrees. So this becomes a 60 30, 90 triangle. And if you remember 30, 60, 90 triangles from your geometry class, kind of do a little sketch here. The short side, we'll call that A. And the longer side is going to be the square root of 3 times A. And the hypotenuse is going to be 2 times A. So we need to figure out this side right here is going to be the x value for our coordinate point, and this side right here is going to be your y value. And if you notice, this is the short side because it's across from the smallest angle, so that's going to compare to our A here. So if we're going to work this out, we know that the hypotenuse, again, the radius is 1, so that means the hypotenuse, which is 2A, is going to equal 1. So A is going to be 1/2. So we know that the x value right here, this measurement here, is going to be 1/2 because this compares to that side A of that triangle. So I'm going to go ahead and put that for first part of our coordinate point. Okay, and then now we need to find the next side, this side right here, which is going to be our y value that's going to be here, which is going to be square root of 3 times A, and since we know A is 1/2, that's going to be square root of 3 times 1/2, which is going to be square root of 3 over 2. Okay, so let's put that on our circle. So square root of 3 over 2. Okay, so let me erase all this extra stuff over here to the side. Kind of get rid of that for a minute. Okay, so now let's go around the circle. We'll have the same triangles for all of these values over 3. It's just that the signs are going to change. So we come to 2 pi over 3 right here. Those coordinate points are going to be negative 1/2 and square root of 3 over 2. And then we get to 4 pi over 3 down here at the bottom. We're going to have negative 1/2 and negative square root of 3 over 2. And then we get to 5 pi over 3. We'll have positive 1/2 and negative square root of 3 over 2. Okay, there you have it. Now we have one more section to do. We're going to now divide this into sixes. Okay, so if we think about the top half of this circle, we're going to divide it into 6 pieces. So kind of think there would be one piece here, one piece here, a piece here, a piece here, a piece here, and here. Okay, so let's do that now. All right, so we'll have right here, we'll have pi over 6. And as we count around this circle, this would be pi over 6. This would be 2 pi over 6, 3 pi over 6, 4 pi over 6. And then we get right here, we'll have 5 pi over 6. And then let's keep counting. So this would be 6 pi over 6. And then we get here 7 pi over 6. And then let's count some more. So we have 7 pi over 6, and then we'll have 8 pi over 6, then we have 9 pi over 6, then we'll have 10 pi over 6, and then last but not least, right there, we have 11 pi over 6. Okay, make sure that looks like an 11. Okay, so now we can draw another triangle to represent that. And let me erase this right here so that we can have not so messy of a circle. That's pi over 3. Okay, so now we would draw a triangle over here at pi over 6. Another right triangle, 180 divided by 6 gives us 30 degrees. So this is also a 30, 60, 90 triangle, which is like what we had for pi over 3, but except it's turned on its side. So what happens is your x and your y values trade places. So like here, this was the x value, this was the y for pi over 3, but now for pi over 6, they're going to trade places. So we're going to come over here, and at pi over 6, it's going to be square root of 3 over 2 and 1/2. Then we come over to 5 pi over 6, we get negative square root of 3 over 2 and 1/2. And then down in the third quadrant, we have negative square root of 3 over 2 and negative 1/2. And then over here at 11 pi over 6, we're going to have positive square root of 3 over 2 and a negative 1/2. And there you have it, y'all. We just derived the unit circle. So let me erase this one thing so you can get an overall look at it without all the extra triangles there. I'll fix that. And so we have here is pi over 6. This one was pi over 4. And 0 was there. Okay, there you have it. There's your unit circle.